If you've taken time to look at our textbook, it is called Functions and Change. And so one of the fundamental concepts for the semester is the idea of functions. The first thing I'd like you to do is to think back. Do you remember any details about functions? So some of the terms that you might think of are domain and range, and they are the words that refer to the x and the y, or the independent and dependent variables. With notation, you might remember f of x can be used instead of y. With the definition, you might remember the idea of something being one-to-one. Examples can be almost any equation, such as a linear function or a logarithmic function. A related concept that might come to mind is that of an inverse function or the vertical line test. Let's take a look at some of these key terms and what they mean for functions. Our first term is domain, and there's a lot going on when we think about the domain of a function. So when we're talking about domain, some of the other words or related concepts that can be used is that the domain is equivalent to the x value. It is the independent value, and it's independent because you get to pick what numbers you would plug in, whereas the y value is dependent. It depends on what you plugged into the formula. It is the input variable, and so it's where you put numbers into the formula. When you're graphing, it is graphed on the horizontal axis. So those are some related terms, but what is the domain? So the domain is the list of all values that will work in the function. And so because it's a list, it might have some, not be all real numbers, but it might be all real numbers. And so related to this idea that the domain is the list of what works, the domain restrictions would be the numbers that don't work. So the x values that don't work. So what does it mean that they don't work? Well, it means that you try to plug the x value in and your calculator gives you an error message. It's something that we don't have a definition for, or something that would take us out of the real number system. So restrictions occur from two different mathematical operations. So the first way that we can get descriptions is when the problem has division. So the function has division, and when that happens, we must restrict the domain so that we don't divide by 0. And you may remember that division by 0 is undefined, and so that's why we can't divide by 0. That's going to be a number that we plug into the function and it would not work. Our calculator would give us an error, a computer would give us an error. It's not able to be done. So we have to do that restrictions. So let's look at an example. We're going to use function notation for example. So we'll use f of x equals 3 over x plus 2. Well, right away, when I look at this function, I see an equation that has division. So that means there's going to have to be a restriction because I don't want to divide by 0. And so just using mental math, I'm like, well, what number would make this 0? And so this is 0 when x equals -2. Because -2 plus 2 would be 0, and then I'd have 3 divided by 0, and my calculator would give me an error. So the domain for this function is going to be all reals, which is short for all real numbers. So all reals, except x equals -2. That's the one that doesn't work. The second case where we could get a restriction is that if the function has a square root. And it's more than just a square root. It has an even root. Square root is the most common. But if it had a fourth root, that would also provide a restriction. And in this case, we need to restrict the domain. So we don't take the square root of a negative number. And you may remember, and you also may not remember, but when we try to take the square root of a negative number, so if we tried to take the square root of -9, our calculator would give us an error. Because when you take 3 times 3, you get +9, -3 times -3, +9. You can't work backwards and take the square root of a -9. It just doesn't work. You also may remember that we have a construct for that with the imaginary and the complex numbers, which we'll deal with much later in the course. But for now, we're going to have to restrict the domain so that we don't go into those imaginary or complex numbers. So let's take a look at an example. And so for this one, again, we're going to use that function notation. And so we'll go with f of x is equal to the square root of x minus 8. So similar to the one above, where the first thing I did is I just looked for when does that x value produce a 0 in the denominator, I'm going to look for what x value would produce 0. And I can clearly see that when x is 8, so if I have x equals 8, I would plug that in. And so I'd have square root of 8 minus 8, which is square root 0, which equals 0. So that is the boundary. And so one side, numbers bigger, or the other side, numbers smaller than 8 is going to be the answer. So let's look at numbers bigger. So what if x equaled 9? So I'd plug that in. So I'd have square root, I plug it in where the x is, so 9 minus 8 would be square root of 1, which is 1. So these two, both perfect, work out great. So they're definitely in the domain because the domain is the values that work in the function. Now I want to go to the other side. So the other side would be smaller than 8. So what if x equaled 7? And so I plug that in where the x is. So I have square root of 7 minus 8, which is square root -1. And that's where my calculator gives me an error message because the square root of -1 is defined as I, an imaginary number. That doesn't work. And so from this, I can see the number 8 worked, the number 9 worked, and I can just mentally be like, well, 10 would work, 11 would work, but anything smaller than 8 would not work because 0 is the boundary between positive and negative, and anything smaller than 8 is going to give me a negative number and not work. So the domain here in words is, so domain is numbers bigger than 8. Those are the ones that work. Mathematically, we would say that the domain is the x value, so that's where x is greater than or equal to, and we do include the equal to because 8 was square root 0, and that worked. That was not an issue. So greater than or equal to 0. No, I said that wrong. Greater than or equal to 8. That's what we figured out. Numbers bigger than 8. Sorry about that. So when we're looking at domain, it is another word for the x value. And the math that we do with domain is look at the restrictions, because we want to know when is this problem going to work. And for most of the functions out there, the domain would be all real numbers. So let me show you an example like that, and then we'll end this video. So if we had our function f of x, we'll do a linear one, negative 3x plus 10. When I look at this function, there is no division. No division. So scenario 1 does not apply. I look further, there's no square root. So scenario 2 doesn't apply. So from this, I would say the domain is all real numbers. And that is the most common domain that we're ever going to have, is all real numbers, because only a few problems are going to have division or a root. So most of the course is going to be spent on these problems where the domain is all real numbers. And then we will circle back to these concepts towards the end of the course and look at restricting the domain and how do we graph with a restricted domain and all of those details. But for this week, domain is the x value. That's a really big concept here at the beginning. That's what it means. And domain is the list of what works. And you might have either of these restrictions based on the problem that you're dealing with.